All right, good evening here, everybody. This is Wednesday, September 16th, and we are watching a developing hurricane out in the Atlantic. This here is it. It is Hurricane Teddy. He is a Category 2 with winds of 100 miles per hour and expected to become a major hurricane over the next couple of days. And you can already see there's very bright cloud tops associated with this thing. It is using the ocean heat content right now. You can see it blossoming, pushing out these spiral bands. It is a very impressive feature already, and it's probably only going to become more impressive as it moves northwest over the next few days. We can take a look at the track from the National Hurricane Center and what it has going on right now over the next 5 days out to Monday, and you see it's a pretty simple path out to that point. You see it has it moving in a general northwesterly direction, and then like so many hurricanes do when they're out in this position near Bermuda, they begin to turn north, and as they would at least 99% of the time from this position, they would turn northeast. But we're going to talk in this video why that might not happen here. I'm not saying that it is not going to turn northeast, but there's some reason to believe it might not, and why we're going to have to pay attention to this. So here is the National Hurricane Center's track. You can see the intensity. It has it becoming a major hurricane by tomorrow afternoon, and then continuing to be a major hurricane to Saturday before a little bit of weakening as it approaches Bermuda, and that's actually due to some upwelling from Hurricane Paulette. We can see this on Levi Cohen's site, where he has the sea surface temperatures laid over top some of the model runs here. And if you look up towards Bermuda, up over here, you can see some cooler water that has been left behind from Hurricane Paulette. So that's something that we're going to have to watch as Teddy moves up here. It will be a big difference if he moves directly at or just to the west of Bermuda, because there's a lot more ocean heat content 100, 200 miles to the west of Bermuda, and that's something those are the type of details you really can't tell 5 days out what's going to happen one way or the other. But that's something important to keep in mind. Some reason why the National Hurricane Center here has some weakening back to a Category 2 at that point. But either way, whether it's a Category 2 or a major hurricane, he will be a very large and dangerous storm in that time, and folks in Bermuda should take note of that. All right, so let's go to the steering currents now, because this is where things get really interesting, because it's beyond day 5 where we start to run into some issues. So first of all, here is the GFS. This is what it shows at around day 5. You see it here, just like the National Hurricane Center and pretty much any other model has. It has the GFS. It has Hurricane Teddy out here sitting just south of Bermuda and getting ready to make an exit stage right. And in this map, we notice a couple of things. We do not have much ridging to Teddy's east, and we have a big open wide lane over here for him to exit as normal. That's what typically happens with hurricanes in this position. And we don't see anything of note back in this area, which is going to be key, that I'm going to get to in a second when we show some other models. So when we start rolling this forward here, we move into Tuesday. This is out here at day 6. And then out here until Wednesday, you see he blossoms into a hurricane. He might get a little bit close to Newfoundland on this run, but he still stays just south of it, and harmlessly out to sea he goes. Now what we want to do is we want to take a look at the European model, because it is showing something different up in the atmosphere. And here you can already tell what we're looking at here. So if you look at day 3, here you see the ridging out in the northeast of the storm, as it moves northwestward. And you see this trough coming down. We saw this trough on the GFS as well as it lifted out, but it's different on the Euro for this reason. Now, the Euro has 24-hour frames, so we're going to jump forward. So this is Saturday morning. We're going to jump forward now to Sunday morning. You can see as that trough starts to lift out, you see both ridges starting to flex their muscle. That's this ridge over here and this ridge up in the central part of the United States and Canada, the central part of the North American continent. And I'll play it back again. You can see these two ridges getting closer together by Sunday morning, and this piece of the trough getting left behind. And if we play it forward again, watch what happens as we head into Monday morning at day 5. Now, right there, the two ridges connect. So this is Sunday morning, Monday morning. Watch for that connection, and that is what is so different. If you go back, this here is the GFS at the same hour. You see there's this wide open lane for the storm to exit which is what it does, and which is what most storms do. But the European model, if you just watch this area right here, closes off the exit by linking these two ridges together and closing any door. It's physically impossible for the storm to go through this while the door is closed. Now, if the storm were to just sit out here, like it usually does if a door is closed in the North Atlantic, again, you have no problem other than for interest in Bermuda. But there's another wrinkle to this, and if we play it backwards a day here again on the European model, it is this piece of energy that is left behind. This is what becomes what is known as an upper level cutoff low. And the problem with these features is that they can tug on hurricanes if they get in the right spot. So again, Sunday morning, Monday morning. And if you watch that, I'll play it back one more time. Now watch the upper level low feature. The energy gets left behind and it closes off. And what's going to end up happening here is because this exit, that the normal steering current is closed, this upper level low on the European model is going to grab Teddy and slingshot him back towards Maine and Nova Scotia, which is a very extreme solution and something that, quite frankly, would be a record setter up in this area if something like that happened, because there's just not that much a historical context of something like that happening, because you need a lot of things for it to happen. You need two ridges to meet, as we see here. You need this cutoff low to be here. It is not here in all the models. And you need a hurricane to happen to be in that spot at this right time. So it's a very, very extreme solution, but it's one that's not impossible. And, you know, I haven't seen many hurricanes do this. It's a rare thing, but there are some examples, if you go back far enough, where, you know, things close to this have happened, but not quite in that fashion. And I'm going to get to more of that in just a moment. But first, I want to talk a little bit about why this is happening at another level. And there's another model here. This is the Icon model. It's a German model that it really shows what the European does pretty well. So we're going to use it here. Watch, this is 500 millibar energy. This is energy up in the atmosphere and shows how it cuts off. It's this energy that's coming down over the Great Lakes on Saturday night into Sunday. So if we play this forward, you can see how it starts to get stressed by Sunday afternoon. You see this big buckle over Pennsylvania and New York. This is being stressed because as the trough lifts out to the northeast of this, and those two ridges work to close, this energy back here is getting left behind. And if we continue to play it out forward more towards Monday, what eventually will happen is that low cuts off. And you see that really, really well here. And this is the extreme solution. Now, whether that low cuts off on top of New England, south of Long Island, over Delmarva, even back inland, that is unknown, and that's something that, if it even happens, is going to be very, very difficult to pin down. But this is the type of extreme scenario that could play out if things go wrong and those ridges close off. And if you watch what happens here, here's Teddy. He's just, you know, doing the normal thing that hurricanes around Bermuda do. He's headed northward. But then as this plays out, watch what happens. There's going to be an interaction between these two pieces of energy. As we play it forward, right there, you see this 500 millibar upper level low reaches out and grabs Teddy. And once he is grabbed in the upper atmosphere, he is going to be slingshot back to the north and eventually to the west for what would really be an all-time solution. On this particular run, he approaches Cape Cod. That would be really extreme. But again, this is what is possible if you check all of these boxes. And now this would be concerning if it was just, you know, the regular European run or a little model like here in the Icon run showing this. But what's really concerning is when you look at the European ensemble sweep. This is where they run the European model 50 times over, 51 times over actually, with slight variations in the atmosphere to try to make sure that the original run was up to snuff. And this right here is on the Weather Nerd site, and they show this very, very well here in the European ensemble. So here we are, day 4. So this is, you know, Hurricane Teddy coming up south of Bermuda. Again, not much disagreement at that point. And then he begins to lift north at day 5, and you see this is where now he's beginning to interact with these lows. You see he's rocketing northward. He covers a ton of ground, and then because all of the European model ensembles agree with the operational model, watch what happens on day 6. All but 3 of them get hooked back towards either Nova Scotia or eastern New England. Now, whether these actually all make it back into New England if they're heading in this area, that's something that we would not know for a few days, and hopefully we'll not even have to deal with at all. But that could become a very, very concerning question over the next few days. And the other concerning thing is, if you go back, Hurricane Sandy was this type of pattern. The Euro nailed that. And Hurricane Joaquin, which did not hit the United States, was also this type of pattern. And on that run, the Euro had the Joaquin going out to sea, and all the other models, like the GFS, the American model, and the Canadian, and the British model, all had Joaquin hitting the United States. So the Euro tends to do very, very well in these cut-off low type patterns. We're going to see if it does well here, because right now all of the other models have Teddy passing out to sea. But the Euro and its entire ensemble package, or just about, except for these three here, have the storm hooking back. Now, here is one reason why you might want to bet against this scenario. And this here is the historical hurricane tracks model from NOAA, or not model, but site from NOAA. And what I did here is I looked up, I ran a query for every storm that passed within 100 miles as a hurricane of Providence, Rhode Island, so I could kind of cover the southeastern New England area here. And what you notice here by all of these lines is that pretty much every single, not pretty much, every single hurricane in the record book came from the south. Now, if I actually move this a little bit further over so you can see it. The two in question here, this one here is the unnamed hurricane of 1936. This one is scooting out to sea to the east, so that came up from the south in a normal position. And this one here, Esther, actually she is both of these lines. She made a U-turn, if I, came around here. She made a big U-turn and made a big loop to the south. So but she initially came from the south over here. And this other unnamed storm from 1896 also came from the south. So the point I'm driving at here, nothing came in from the east like this is showing. So this is not in the historical record going back 400 years. There's only one storm on the historical record that I could find that passed east of Bermuda and ended up making landfall in New England. That was a tropical storm in 1923. So because it didn't reach hurricane status, it doesn't count, and it was not like this. This would be a unique scenario. So you look at it and say, well, it hasn't happened in 400 years, so it's a good idea to bet against it. Problem is, I also remember sitting here 8 years ago saying, well, no storm has ever hooked into New Jersey like that, and that ended up being Sandy. So it's possible the Euro is good with these types of storms, but I would say at this point it still remains unlikely, because it would be so unusual and so many pieces have to come together so perfectly to get the wild scenario next Tuesday. But just know that next Tuesday, if something does happen, is the day it would happen, and keep an eye to your local weather forecast, and I may try to provide some other updates here if things continue to look interesting. And that's just something to keep an eye on, because we may be dealing with something significant next week, or the European model could drop it, and we could be back to a normal scenario, and Teddy can do what 99% of other hurricanes do. They get near Bermuda, and that is go harmlessly out to sea after possibly impacting the island. So that is all for tonight. Stay safe, everyone.